Yeah, okay. Today we'll start about this new topic that is threats. Threats. Okay. So what are these threats? We'll see. Okay. Yeah. Threats. Threats. Okay. Suppose in Verilog, we return one code like initial begin, and some a equal to 0, hash 10, a equal to 0, hash 10, and b equal to 1, hash 20, and c equal to 2. Okay, and end. Okay, end. So that means this will be executed as this is a blocking operator. So this will be executed sequentially. This will execute sequentially. Okay, so this will execute sequentially. So here we already seen that thing. Whatever the non-blocking are there, that will be executed. That will be executed in which region? That will be executed in NBA region. That will be executed in NBA region. Okay, so if you want to execute it in active region, you need to use a non-blocking operator, and that concept we already seen in the um, in the Verilog. Okay, suppose if you want to execute parallelly, okay, if you want to execute these instructions parallelly, so what you need to do, you need to use this threads concept. Okay, so threads. So threads means threads. So you have fork join, fork join, and next you have fork join any, fork join any, and next you have fork join none, fork join none. Okay. So these are nothing but particularly these blocks will execute parallelly. Okay. So these blocks will execute parallel. These blocks will execute parallel. Okay. Suppose if you consider one example, if you consider one example, um, initial, initial, begin, initial begin, suppose Ashton, Ashton, and here I am writing fork. Okay, I am writing fork, begin, begin, hash 20, hash 20. Okay, dollar display, dollar display, uh, thread one, thread one, and end, and begin, dollar display, dollar display, thread 2, thread 2. Okay, here end and join, join and end. Okay, so in this this is nothing but one block. Okay, so this is block one of one thread. Okay, thread, and this is thread two. Okay, thread two. So which one will be executed first? So it is having the delay of what, 20. Okay, so which is having the least path, that will be executed first. So this is having 0 time units. Okay, so this will be executed. So which is having the least path, that will execute first. That will execute first. Okay, so means first it will be executed, and next this one will be executed. This one will be executed. Okay, that is nothing but fork join. Okay, I wrote some programs related to fork join. If you see, one second, I'm opening. Okay, playground. So if you see the fourth join, yeah, omitting the EDA playground. So this is fourth join. Okay, this is the program for fourth join. Uh, so if you see module fourth join, initial begin, fork, begin, and hash 20 dollar display thread one, end, and begin hash 30 dollar display thread two, end, and join. Okay, dollar display displaying the outside the fourth join. Okay, this is one more display statement and we're playing outside the fourth join block end and end module. Okay, so which is having the least path that will be executed. Okay, so just I'm copying this and I'm seeing in the EDA playground. Just paste this, run this. Okay, so I want to select the simulator, Aldec Rivera, run. So see here, first thread one is having the delay of what 20. So thread one is executed. So which is having the least path that is executed. And next thread two is executed. Okay, thread two is executed. And after that, displaying outside the fourth join is executed. Okay. Suppose here, suppose here I am giving delay is 50. Okay, and I am running this. So, which is having the least path. So, if you compare 50 and 30, so thread 2 is executed first and thread 1 is executed next. Okay, 30 and 50. After that, displaying outside the fourth join block is executed. Okay, so this is about the fourth join. And next is uh, fourth join any. Okay, fourth join any. Okay, so fourth join any is nothing but here. Same thing I wrote, but here what join any. Okay, fork. So this will be thread one is executed between 20 time minutes and thread two is executed 30 time minutes and join any. Okay, so if this I'm executing fork join any. Okay, so when I'm executing this, just copy this. I'm seeing in this VDA playground. Run this code. So fork join any is nothing but depends on first thread one is executed and next displaying outside the fork join block is executed and for thread two is executed. Okay, so that means it will not follow any least timing path. Just it can execute. So first thread one is executed and next displaying outside the fork join will be executed and thread two is executed. Suppose if I change here with 50, so when I run this, we'll see which one will be executed. So that means we can analyze what is happening. So thread 2 is executed. So that means thread 2 is executed means which is having the least path that is executed after the displaying outside the fourth join is executed and next thread 1 is executed. Okay, so like this, this is fourth join any. Okay, and fourth join any, this is another program. Same thing, I change the time path. Okay, that is fourth join any. Okay, and fourth join none. Okay, fourth join none means suppose if you see fourth join none, module fourth join nine initial begin fourth begin and for hash 20 displaying thread one and hash 30 displaying thread two and fourth join none. Okay, so what it will execute will see fourth join none. Just copying this. I'm seeing in the video playground fourth join none. So fourth join none means what? First. So fourth join none means first this is displayed. After that, inside thread one and thread two are displayed. Okay, that is nothing but fourth join none. Okay. So in this threads you have three types. That is nothing but so in order to execute parallelly, suppose if you are going for Verilog, if you are using blocking assignments, those will be executed sequentially. That should be executed in NBA region. Okay. So in order to execute that blocking operators parallelly, you are going for what threads in the system Verilog. Okay, threads in the system Verilog. In the threads, you have fork join any, and fork join none. Okay, so this is about fork join. Okay, and next we'll see the SV test bench. Okay, SV system Verilog test bench. Okay, so what is this SV test bench? We'll see. Okay, so SV test bench. In SV test bench, first there is a top test. Okay, there will be in top module there is a test. Okay, in this test again there is a generator. Okay, there is a generator. Okay, so that means that this is total. We can write this is a total top. Okay, so this is total top. Okay, and in this top, so there is this is environment. This is nothing but we can call as environment. This is environment. Okay, this is environment. In this environment, you have a generator. Okay, and generator, and you have a scoreboard, scoreboard, and next you have reference model, and you have so this generator is connected to driver. Generator is connected to driver. This is my driver. Okay, this is driver, and from this generator it is connected to scoreboard also, monitor. It is connected to monitor, and so this driver, so this driver, and from this monitor it is connected to DUT. DUT is nothing but design under test. Okay, this is connected to DUT. Okay, design under test. So how they are connected means through a concept called interface. Through a concept called interface. Okay, so so here this is top module. Okay, this is top module. So so interface, and this is also connected like a interface. Okay, interface, and so you will get you have the concept called components and objects. Okay, so that means this is nothing but transaction class. Okay, transaction class. Okay, so you have a concept called components components and objects. Components and objects. Okay, so we'll see all these things. Okay, so here so this is the basic structure of test bench of SV. Okay, so here if you see the RAM, so I'm trying to explain the test bench with respect to RAM. Okay, so we already seen the RAM in the Verilog, no? So RAM, if you see, this is 8 cross 8 RAM. 8 cross 8 RAM. So 8 cross 8 RAM means what? It consists of 8 locations, and each of how many bit? 8 bit. Each of 8 bit. Okay, so that means here in the, so what is the range? What is the range? Range is from 0 to 2 power 8. This is the range. Okay, so here how this SV will do the test cases means like packets. Okay, so packets means so you have like 50 0 to 50 50 module. So it will do, this is let us take test one. Okay, and next 50 to 50 to 250 things. So this is it will do with test 2 like that, sir. It will make its packets packet wise. It will do the test. It will do the verification. Okay. So test cases. So what are the test cases? Test cases are nothing but first writing the simple test cases from the test class. We are inheriting the child class. Okay. So that means here we are using in the test bench. We are using the oops concept. Okay. So that means we are writing simple test cases. Okay. So test cases and we are inheriting. Okay. Inheriting the child class. That is nothing but a concept called inheritance. Okay. So what are test cases? How we are writing the test cases in System Verilog? So we are writing the test cases. First you are writing the simple test cases. Okay. First writing the simple test cases. Simple test classes. Test classes. Okay. So test classes from the test. From this test class. From this test class, we are inheriting the child class. Inheriting the child class. Okay. This concept is nothing but what we already seen in the oops concept, no? So there is a concept called inheritance. Okay. So that means you have a parent class and child class. So you are inheriting the parent class properties to the child class by a keyword called extern, no? So we already seen. Okay. And so there is a concept. So in this there is a concept called functional coverage. There is a concept called functional coverage. So what is this functional coverage? So in the functional coverage, it should cover 100%. Then only your design is achieved for 100% success. Okay. So then only your design will acquire 100%. So when it will acquire 100% functional coverage, then only your design will acquire 100% success. Okay. So this is about mm, uh, the uh, test cases, how we are writing the test cases. Okay. So we'll see each and everything one by one. So what is this environment, what is the generator, and what is this driver, monitor, all those things we'll see. Okay. So first is environment. Okay. So what is this environment? First one is environment. Okay. So what is this environment? Environment is nothing but it's like a holder. Okay. It's like a holder. Environment is like a holder. Okay. So it is like holding all the components. Holding all the components. Okay. Holding all the components. Suppose if you consider any system on chip, SOC. Okay. So if you consider SOC, it consists of what? UART, UART, and SPI, serial peripheral interface, and I2C IP. Okay, these all are nothing but IPs. Okay, intellectual properties. Okay, and so that means here what it will do. So it will make all this may this all this it will make an environment and it will hold all this it will hold as a test. It will make an IP and it will make a text. Okay. So this is the environment. Okay. And next coming to the generator. Okay. What is generator? So first one, so there is a generator. So generator, for generator we'll take the example of RAM. Okay. So RAM, we already seen the RAM design in the Verilog. Okay. So RAM design, this is 8 cross 8 RAM. So if you see the 8 cross 8 RAM, what are the inputs? Clock is one input, reset is one input, and write enable is one input, and read enable is one input. Okay, and next data in is one input. Okay, this is of 8-bit. Okay, and this is RAM, and write address is one input. This is 3-bit. Write underscore address, and read underscore address. This is also 3-bit. Read underscore the read underscore address, okay. And data out, data underscore out. Okay, this is 8 bit. Okay, so here what you are doing means you are you are providing the stimulus. Okay, so you are providing the stimulus to the RAM. Okay, so you are providing the stimulus to the RAM, providing the stimulus means for text vectors. Okay, so what are the stimulus? Write enable, read enable, and data in, and write address, and read address. Okay, so how we are providing the stimulus by a concept called randomization. Okay, we already seen the randomization, no? So randomization means randomly we are generating the values which are being provided by the design. Okay, so that is nothing but concept of randomization. Okay, we are using a keyword called rand, no? Okay, so that means here we are generating the values which are provided by the design. Okay, but that is nothing but randomization. Okay, so for this, what you are doing for this randomization, you are using a keyword called what? Rand. Okay, you are using a keyword called rand, and next rand reg write enable. Okay, rand reg you are writing read enable. Okay, and next rand reg 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 2 down to 0, 2 down to 0. So what is that? Write address, write underscore address. Okay, and rand reg 2 down to 0, read underscore address. Okay, and rand reg, so this is 7 down to 0, no, 8 bit. Okay, read data in, data in. Okay, like that. Okay, so you'll initialize this, and after that what you are doing, you will wrap them into class. Okay, so you are writing class transaction, okay, rand reg write enable. Okay, and rand reg read enable. Like that you are wrapping. Okay, wrap them in the class. Okay, you are wrap them in the class, okay, and end class. Okay, so so what is this transaction class? Not involved in the test bench. Okay, so they will be not involved in the test bench hierarchy. It is a standalone class. Okay, so transaction class is not involved in the test bench. That just it is a standalone class. Or transaction class is nothing but it's like a bucket. Okay, it's like a bucket. Transaction clock is it's like a bucket. It's holding all these variables. Okay, that is a transaction class. Okay, and next what you are doing, so you initialize in the class, okay, all these variables, okay, by using randomization. And after that, what? Class generator. Okay, so what is this class generator? Class generator is nothing but, so here these all are nothing but objects. What are these objects? So these are nothing but objects. Okay, so these are objects. Let us take these are in t underscore h. What are those objects? Write enable, read enable, and write address, and read address. Okay, data in. These all are nothing but objects. These are holded by t underscore h. Okay. So how you wrote? So you already remembered how you wrote the objects means how you wrote. You need some handle, no? So that is transaction. What is the handle I'm using? T underscore h, and I need to create the object. How you are creating the object with the help of the handle? So t underscore h equal to what? New. T underscore h equal to new. And how to randomize these values? T underscore h dot randomize. T underscore h dot randomize. When you calling this function, all those values will be randomly. We can give these values to write enable, read enable, write address, read address, and data in, like that. Okay. So I'm using what? Dollar display. dollar display t underscore h dot write enable. Write enable. Okay. So write enable means what it is display the random values. It will display some random values. Random values. Okay. So that means here what you are doing here, there is a generator. Okay. So there is a generator. So what is this generator? There is a handle. What is my handle? T underscore H is the handle. Okay. So T underscore H is the handle. You are generating the random values. You are generating the random values. Random values. So with the random values, you are sending the objects to the driver. Okay. You are sending these objects. Okay. You are sending these objects. What are those objects? All those inputs like write enable, read enable, read address, and data in. Okay, all those are nothing but you are creating one object. Okay, so you are sending these objects to where two objects to driver and monitor. You are sending these objects to driver and monitor. Okay, so that means how I am sending means you are using a concept called mailbox. How I am sending this one? So you are using a concept. Okay, so how I am sending? You are using. So you are sending these objects, sending these objects to generator and monitor through a concept called mailbox. Through a concept called mailbox. Okay, so mailbox is nothing but it's like a FIFO only. Okay, it's like first in first out. We already seen no FIFO. Okay, so this is a mailbox. Mailbox. It's like a FIFO only. Okay, FIFO. Okay, it's like a FIFO only. Okay, so that means so here after driver and monitor receive from the generator, so what it will do? So like suppose here generator, you have generator, and here through the generator you are sending the objects to driver and monitor, So here, how I am sending. So this is a RAM design. This is my RAM design. So for this RAM design, so there is an object. There is an object. Okay, this is my object. Okay, which is having the handle T underscore H. Okay, so inside the object, what will be there? Write underscore enable and read underscore enable. Okay, and write underscore address. Okay, so this write underscore address. These all I'm sending to this RAM design. Okay, by creating an object. Okay, by creating an object. Okay, so here some points I will write. Okay, so generator sends the data in the form of what? Package to driver. Okay, generator generator sends the data in form of what? Packets. Okay, in form of packets to the driver. Okay, driver will convert packet into pin level configuration to the design using interface. Okay, so what the driver will do? So driver will convert the packet into pin level configuration to the design using interface. using interface. Okay. So suppose 100 data lines are there. Okay. To randomize, send it to the driver. Driver will open up and send it to the design. Okay. Suppose you have 100 data lines. 100 data lines are there. Okay. So these 100 data lines, what you need to do? So this you need to randomize. Okay. This 100 data lines you need to randomize and send it to what? Send it to driver, and driver will send it to the design. Driver will send it to the design. Okay. Monitor is going to monitor what the driver is sending. Okay. What is the purpose of monitor? So monitor is going to monitor whatever the driver is sending. Okay. Whatever the driver is sending. Driver is sending. Okay. So duty of monitor is everything. Okay. So like this, a monitor will check whatever the driver is sending. Okay. So remaining part we'll see in the next class. So today we discussed about this threads. Okay. So basically in the Verilog, like whatever the blocking operators are there, those will be executed in NBA region. Those will be executed sequentially. So in order to execute those operations parallelly, so we are going for fork join any and fork join none. Okay. So that is some programs we already seen. And this is the SV test bench. So in the SV test bench, there is a transaction class test. Inside there is an environment. Inside the environment, there is a generator, and generator is connected to driver and monitor. And there will be a scoreboard within the environment. There is a scoreboard and reference model. This we'll see in the next class, scoreboard and reference model. So I am trying to explain the test bench operation with the help of what example 8 cross 8 RAM. So how the environment will be there, how the generator is there, and we are using the concept called randomization. Okay, we are randomly generating these values. After that, I'm using a concept called OOP, and I'm creating the object with the help of this. Just transaction is nothing but a bucket, and we are generating the class. Means we are creating the class. We are creating the handle. With the help of handle, I'm creating the object, and I'm randomizing. I'm displaying the values of in this. Okay. So like this, it will. So generator will send all those things to the design. Okay. So this is about the test bench. Okay. One second.